So my name is Juncheng Yang. So I'm assistant professor in computer science at Harvard School of Engineering and Applied Science. My research is mostly on computer systems, and my group cares about performance, sustainability, efficiency, and reliability of computer systems. So we look at problems such as how we can make computer systems faster, how we can make them more sustainable, reducing the carbon emission of those modern data centers. And we also look into questions such as how we can improve, say, the utilization of computer system so that with the same hardware, you can get better performance. So storage is a big component of modern computing systems. Like if you look at data centers, storage actually accounts for 30% of the carbon emission from data centers. So if you look at the amount of data our society generates every year, it grows exponentially. For example, last year, our society generates almost 100 zettabytes of data. That's a lot of data, right? And if you accumulate those data over time, that's even more. We keep generating new data, while the old data still stay there. So another direction we're looking into is how to store those AI-generated data more sustainably. So we all use ChatGPT today, right? ChatGPT generates text response. They're not too large, but we also increasingly use video and image models where we generate images and videos. And those images are much larger than text. For example, the image generated by, say, Nano Banana is usually 1 megabyte or even sometimes larger than that. And according to some study, in 2023, our society generates 16 billion of images. That's 16 billion. If each image is 1 megabyte, that image itself will consume 16 petabytes of storage space. And that's 2023, right? This year, the number will be much, much larger. So we look into sustainable storage. We try to design better algorithms and systems so that we can store data more sustainably. So a few of directions we're looking into includes better compression and deduplication algorithm. For example, in the coming year, we have a paper on how to store large language models more sustainably. Those models consume a lot of storage space, and also the number of models also grows over time. So we calculated the number of models and their storage consumption. It's projected that in 2027, those models themselves will consume 1 exabyte of storage space. We look into how to store those models more efficiently. We find some patterns between different models, and we use better compression algorithms and better deduplication algorithms so that we can reduce the footprint of storing those models. So that's one area we're looking into, better compression and deduplication. We also look into things like how to place data on different storage devices so that we can leverage the characteristic of different storage devices. How do we choose the best combination to compose the whole storage system? So sustainable storage is one area we're looking into. And the other area we're looking into is the performance of computer systems, especially storage systems. And so there's something called a cache in computer systems. So cache is basically a fast and a small storage device, and we can store frequently accessed data in a cache so that future access to those data can be very fast. However, because they have limited space, there's a challenge, which is which data we should store in the cache. Right, so we look into different algorithms and system designs to improve the cache efficiency, so that we can have more data that can be served from the cache using the same amount of space and same storage device. So besides performance and sustainability, my group also cares about reliability of large-scale systems. So many of you may have experienced the AWS outage a few days ago, right? So many of our activities relies on those digital infrastructure, and the reliability is super important. So our group looks into how we can build more reliable infrastructure without spending more resources on them.